Okay, hey, hi everyone. Just thought I'll do a show and tell on the ROS Node Testing that I've done, and I hope it would be useful to you all, and I hope it can save time for you in your development. What I found is to start up the simulator and then run the launch files requires quite a number of seconds, and at the same time to shut it down requires another 5 or 10 seconds. That's time that you could be coding and debugging your code. Additionally, as we start testing or developing features like traffic light and all of that stuff, you're going to have to drive the car around and before you can validate your code change. So the question is there a way to develop without having to run to the simulator every line of code that you change? And the solution to that is to start using ROS Node Testing. The idea is you run the node that you want to test, and you run another node that will inject data by emitting data to publishing data to various topics that your node is listening to, and then it will listen on the topics that your node is actually publishing. So just to validate that your node is doing the correct things. You can actually use this to do load testing and things like that, but we're not quite there yet. Okay, to start off, I have modified the README to add a number of things. So one is ROS, even though I say unit testing, it should be node testing. So you can run a specific test by just doing ROS test minus text. The minus text param will allow you to see all of the log info, rosp.log info, log error, log warning in your console of the test output. Otherwise you just see a success or failure. To run all unit tests is just running cat can make run test. Actually you probably want to and then do a source, do that first and then run that. I've also created a little utility tool which is inspired from doing web development, where you've got a tool that changes or watches for file changes in a specific directory, and it runs a set of unit tests. So in this scenario, we're watching the source folder from the ROS directory, and it's executing this specific test. And then you could also run all unit tests, and I've also added a little sort of section on, if you want to add testing to a new package, these are some of the steps to actually get it working. Okay, so that's the README. Next thing is, you will notice, let's use waypoint updater as a package example. You'll notice it now has a directory called test, and it has a Python file as well as a .test file. The .test file is essentially a clone of waypoint updater, which just runs the waypoint updater node. Hold on a sec, let me close this thing. If we open up this node test launcher, you will notice that I've actually included a waypoint loader as well. So this is what you will see in Sticks launch, which has a waypoint loader. The reason I included this is because the waypoint updater inherently needs the waypoint loader on startup, because waypoint loader loads the base waypoints and it will publish it to a topic which our waypoint updater is listening on. So instead of trying to mock this node, I decided why don't we just load it up, because they've already written the code for us already anyway, and all it does is load waypoints from CSV file or something. So we don't want to, there's no point trying to mock that since it's a very simple static functionality. Not sure static's the right word, but okay. So that's just running the node that we want to test, and then we have a test tag which points to our Python file. That's as simple as it is. So let's say, whoa. Okay, so how do you run a test? Based on the README, you can just do this. Make sure you're in the ROS file and have, oh geez, and it will have a success. And this thing is pretty random. I haven't seen it impact me too much. I hope it doesn't happen in a real car too often, but I think it's a ROS specific thing anyway. So there's just running an individual test. Let me try and change something to fail it. I think this should fail it. And it's saying it's you know, the value actually came out at 11311919 and doesn't equal to 0. Okay, so that's how you run it. So say I want to make some changes to waypoint updater, and while I'm working I want to be continuously running this test. So we can use this command instead, where it will start watching the source folder and it will trigger this command on file modifications. So if I uncomment this line of code again, we run the test and it will fail like before. Let's change it back. So how is a unit test structured? It's pretty much runs along the same lines as a Python unit test. It inherits, or you import Python's out of the box unit test class, and you pretty much inherit it. You provide a constructor. This I just copy and paste it from the web. A setup. So setup is what you do every time the node starts up, and you have test cases, which the test case method name has to start with test underscore. So if you want multiple test cases, you're gonna have to define something 1, right? And you have something 2. So that's how you can have 3 different test cases. And what happens is this node should start itself up 3 times and run the setup 3 times and execute each test case in an isolated scenario. Let me just get rid of that for now. I've also, in an attempt to understand the different nodes and the messages that get broadcasted, I've actually just used this to subscribe to the current post and base waypoints. It gives me the ability to examine what messages are coming out of it. For example, in waypoint loaded callback, I'm able to log just the first waypoint and the second one selectively without having to see the whole thing, because when you look at it, it's actually I did a count, and there's like 10,000 waypoints. So you can see, you know, waypoint loaded callback, waypoint loaded callback. That's the stuff in the header. You know, I'm putting header stuff. I'm putting a length. There's 10,000 waypoints. When I first tried printing this stuff, it just spammed my console. So yeah, it's provides a convenient way of examining data, and it also allows you to develop or publish your message incrementally. You know, you could add one parameter first and then see what the output looks like and keep going. Okay, so the test case itself, this is a way that I found to work, given that it's all asynchronous. Actually, before that, I've actually had to put a sleep here for half a second, just so it initializes properly, and at the same time I also have to put various sleeps in here, just to make sure there is no race condition happening in the code. So how does it work? I typically define a boolean to indicate whether the callback has been called. I define the callback, and I initialize this boolean to be false. In my callback, if I get a response, I'm going to set it to true, and then I start doing assertions, essentially. And once I've defined the callback, I subscribe to a topic that I'm interested in, and I give it the callback. In this scenario, we're testing the final path procedure, so we're listening to the final waypoints topic, and we're looking to do some tests on top of that. You can also do logs, just so you can see what data is coming out as a form of validation, or you can specifically say, I expect the first waypoint to be equal to this or that. It's probably not good to hard code it like that, but that's how I've implemented it at the moment. So once I've subscribed, I sleep for half a second, and just so it can subscribe properly and there's no race conditions. I've actually tried reducing this to 0.1, and I spent about half an hour trying to figure out why it didn't work, and I thought my whole setup was wrong, but it turned out to be I just needed to increase that a little bit. It seems a little bit nasty, but this is the only way I find that will make it work. Something that works is better than nothing, right? So once I've subscribed, we generate a pose. So what this method does, all it does is create a pose stamped topic, and we populate it with px, py, pz. So these are the values that we actually receive on the current pose topic. When we start the simulator, I simply printed out the values and then extracted out so I can put it into this unit test. And in this unit test, I am just publishing it back. So it's as if the simulator has published the position of the car. That is meant to go into our waypoint updater, into the pose callback. It's subscribing to that, and it's meant to build a path based on where the position of the car is located. So now we can test all of this logic. So once we've published it, I set we calculate a timeout 1 second from now, and we put in a while loop where if we haven't shut down and the callback hasn't been called and we haven't run out of time yet, just keep checking every 0.1 seconds until this eventually comes true, or we time out. So 1 second is more than enough, I think. And in the end, just in case we've timed out, if we timed out, we probably should fail this test. Chances are something is wrong, or we need to modify this value. We should do an assert just in case it timed out and this stays false. So this should always be true. And so that's the gist of a unit test. So for example, and when writing a unit test, you should always write it so that it fails, and then you modify it so that it succeeds. And so yeah, let's say I wanted to examine the entire message. I just do a log. What I like about log warn is in the print, it actually prints out in a different color text with the actual object. I wonder if log error is red. Yeah, cool. So if you want to do different color logging, that's the way to go. So you can see it out of the all white generic text. So yeah, if we want to this is just basic logic I've implemented. I think Mihir is implementing a more complete one. So let's say right now it's just choosing the shortest base points from the car and go from there. But if I need to add, let's say we want to start the first point to be at where the car's position is, then we're going to expect whatever we send to the current pose will be the first position, first waypoint in our result. So we can almost start by changing this as the test set, and then we start changing our codes until our code meets this test. That's one way of doing it, called test-driven development. But I think as long as it helps you to debug, log, and validate your test, your code without having to start the emulator, I think it already saves a lot of time. And that is all. I've only done it for the DBW DBW node there, and also the waypoint updater. And while building the visualization Python, I also created a test file just to help me develop without starting the simulator. So I hope there is enough info for you to create your own. If not, I'm happy to help out. Any questions, also happy to answer. Cool, thanks.